uh, whether how many data items are in each cluster. So that could be one of the metric that we can say, okay, one particular clustering is better than another one, right? So there could be some metrics that we can form which can actually tell us whether one particular clustering is better than other or not. If we do so, then we may be able to identify that one particular uh, clustering may not be a good idea. So we can leave that, we can choose something else.
Uh,
Yeah.
Sorry to interrupt you, sir.
Yes,
Uh,
sir.
we have some time constraint, so it's
Right.
one. So please conclude. I'm really sorry to interrupt,
Okay,
but
okay, okay.
there
Okay,
are
okay.
other scheduled lectures. Thank you, sir.
Okay, fine, fine, sir. I'm sorry. I took a little more time. Um,
No problem, sir. No problem.
so, well, we will actually, I was thinking to start with the linear classifiers, but let's try to finish it here only. I'll just give you a brief idea about SVM. So in case of SVM, we have this kind of thing. So we have certain things that we want to classify into apples or pineapples. And what actually we want to do, we want to come to the situation wherein uh, we have multiple classifiers. So this every classifier can work in this particular part. So we want to look for some classifier which is better. So which classifier we can take? The classifier actually which helps us uh, in giving the robust decisions. Robust decisions again means the same thing, that if you change a little bit into the data, it should not change itself class. So that's the thing that we are looking for. So the idea is what we do, we keep these data points or the classifier, we take two planes. This is one plane, this is another plane. And we want to push these two planes as much away as possible while keeping these data points as it is. They are not going to change, but we want to push these two planes as much away as possible, keeping these two planes parallel as possible. So once if we keep these two planes parallel, the middle plane could be the plane which is the robust classifier. Why? Because if I change or if I have certain noise in this data point, it will try to bear as maximum as possible. So that's the basic idea about SVM that is used, and because of this, SVMs actually works much better than most of other classifiers. So with that, I think I can conclude. If somebody has some questions, they may ask me.
Thank you, sir. So this is for all of you. If anybody is having any query or question, they can ask.
Yeah, hello.
Yes, sir. Yes. Yes.
So good afternoon. Sir, I have a question. Like I'm working on image data set.
Right.
I just want to know for which technique I should go for, to classify the things and not even classification, but for the detection purpose or recognition even.
So you must be looking for. Uh, uh, can you tell me the objects, kind of objects that you are trying to detect?
So the data set is of ears, a
Ear,
human ear.
human ear. So generally,
Yes.
people are using transfer learning and YOLO data set is YOLO algorithm is a better one. So if you take YOLO, it tries to identify a lot of objects, but you have to train it again for your data set. So you use the transfer learning. So already learned data or already learned network you can take, and on that network you can learn it again for the years, and that may help you.
Okay, sir. And if I want to combine it with any machine learning, just in case, like I want to improve the efficiency, like SVM that you explained that it has very good performance, like.
Yeah. Actually, let me tell you one more thing very clearly. In case of machine learning algorithms like SVM and all other things, like whatever is not in deep learning, they don't find features by themselves. So they require a domain expert to actually tell them the features, right? So like in case of iris setosa, iris flower plant data set, you can see we have given only four attributes to it. So those attributes has been found with the help of expert. The expert has come up with this thing that these four attributes are good attributes to distinguish between the things, right? So if you want to find out the object, so the object recognition or object detection algorithms are much better in case of deep learning rather than these things.
Okay, sir. Thank you.
Anyone else want to ask any question? Yeah, Madhur is there, or anybody want to ask? So okay, if not so, then good afternoon to all of you. It's my pleasure to put my vote of thanks to Dr. Kapil Gupta sir. So on behalf of Department of Electronics and Communication Engineering and Chandigarh University Management, I thank you, sir, for sparing your time and enlightening us with the knowledge about machine learning concepts, various uh, associated challenges, and objective of machine learning algorithms. Although I interrupted you in between, but I will be requesting you in future for a few more such lectures. It was really a knowledgeable lecture, and we really thanks to you, sir. Thank you once again, sir.
Thank you for the opportunity and thank you for your, yeah, I always love telling the things, teaching the things. Maybe I took it a little basic. So in future, if you have some kind of advanced thing, I'll be with that.
Sure, sir. Sure, sir. Definitely, we will like to have, but in this semester, it is going to be over by 1 or 2 days. So maybe next lecture when it is going to start, next semester, sorry, uh, we will be definitely in touch you for more lectures. Thank you.
Thank you. Thank you, everyone.
So all of you now need to give the feedback. I have already shared the link of form. Submit the feedback and then you can go for your classes. Thank you.
Thank you, everyone.
Thank you, sir.